This is an overview of the product called Project Vasari. It's available from Autodesk Labs. If I talk about the goals, what I would want to show is that you can use Vasari to create the site context on the illustration on the right. The high-rise buildings, all of the white forms that you see there, or white masses that you see there, could be created in Vasari in a number of different ways. The actual model that you want to study is created also in Vasari. And you have a means to tell it that that is the particular mass model that you want to study. So some of the mass models, or the mass forms that you see there, provide context, shading the site, and some will be the one that you pick will be the one that's actually the building under review. There's many different ways to make mass models, and you'll find lots of movies on YouTube that cover the different techniques outlined here. So the goal would be, in the movies that are produced subsequent to this, would be to prepare a project, create a mass model, run an energy analysis, make changes and look at the results, and compare them side by side, so I can see did the change that I made to the mass model result in something positive or negative in terms of the performance of the building. And then how do you customize surfaces in the building so that they don't have global values applied to them, but each surface can have something different, say in terms of the material or the percentage glazing. Why Vasari? Well, one thing that you'll notice is that your performance on your laptop or your desktop is not affected by the creation of these reports. They're done using cloud computing, so actually this processing is, if you like, off-site. It's independent of the laptop that you have, so you don't need to have powerful equipment to utilize this. The second point would be that you can get results very quickly at a conceptual stage of your design, rather than what you might have had to do in the past, which would be create a more finished building model before you could actually get to the stage where you could create an analysis. So this is an important new development that lets you get quick results early on in the process. And the third point would be that most of us are kind of visual designers, so we're hands-on in drafting in a product like making our mass models, and probably more comfortable doing it that way than, say, entering large amounts of data in a form, one form after another. So it kind of lends itself to the visual designer. How you use Vasari is you create massing models with forms. In the illustration to the right, the only form is the large kind of box shape where you see a volume. You can also create surfaces as masses. So if I wanted to create the classroom, this is all I need, this large volume, and then for the patio and the shading above the patio, all I need is these flat forms. You tell it when you're about to analyze it that this is what you want to analyze by selecting the object and applying mass floors to it. That's how it knows which mass form to run the study on. Other mass forms will be factored in because they create shading on the building, but they're not the actual building being evaluated, only the one that you've applied floors to, or the combination of masses that you've applied floors to. The initial energy settings that you apply are global, but then you'll find out that you can come in and you can customize for particular forms or particular faces. You can run these options by creating reports or doing an analysis. Then you can compare the results side by side. So you can make like a what-if scenario. What if I reduce my building by 3 feet, and then run the results and see what the impact is on the energy analysis. So in this massing, only the elements that have an applied floor are used for the energy analysis. I mentioned that already. This means that in a simple building, you may just create the outside form of the building itself and keep the geometry very simple. But you do have the option, because the model is rationalized per form, of creating more complex buildings. And you could do this on the illustration on the bottom right by having, say, a cylindrical form and a box form, and you can actually kind of customize those independent of each other, and would create them where you think that, okay, I have different zones in the building. It's not all one building, but it's different zones, so I have different forms. I mentioned that masses can have volume, or they can be surfaces only, and I mentioned that masses that don't have the floors applied will provide shading. That's the context of the site that we saw in the previous slides. If we want to go about creating a sustainable building then, or evaluating it, we find that students want to apply their skills and be able to test and validate assumptions very early on. Even these 12-year-old kids that are designing an eco-classroom, they want immediate feedback. They don't want to have to go through the whole business of designing the building first and then getting results to give them the analysis they want. So taking their building as an example, the kids are designing a eco-classroom, and you can see the building here that they have in mind. Passive solar heat from the south, with sunshine, sunlight collecting from the south. Excuse me. A large, massive wall at the back of the building for storing heat. If I look at the roof, I can see the percentage of skylight area that they're anticipating, about 5% of the total. If I look to the east elevation, I can get also percentages of how much light they're anticipating for the building. I can do this for the south, I can do it for the west, and I can do it for the north, where there's almost no openings at all. Well, you don't have to create the complex model on the top left before you can do the analysis. All you actually need is a representation of that building, such as the illustration you see on the bottom right. The students can then pick their location in the world. The red symbol is the location of their project, and they can drag and drop that wherever they want on a map of the world, as it were. By default, any of the weather maps that are available with 25 years data will be available for the study, and by default the closest one to the project will be selected. But you can, it's shown here in orange, you can pick on another weather map in the area that's maybe more suited because of topography or proximity of large water bodies or whatever, to pick something that's the best choice for your site. I'd mentioned that you don't have an energy model defined until you apply a floor to it. So when I say to it in Vasari or that I want to apply level 1 to the model, that's how it knows that this is the mass form that I'm about to do the analysis on. You can then set energy settings. For example, here what we're saying is it's a school or university, and we're going to create the energy model, and then we want 80% of glass, and maybe for the skylights assuming 5% that I'd mentioned and showed in the illustrations before. And you can pick an HVAC system. Well, all of these defaults get applied to the model, and you can see that the model is immediately converted without any drafting on the part of the students. They now have surfaces representing the glazing. Result is quick. It's not maybe exactly what you want, right? You click the button and you got this default because the global settings are applied, but realize that you can then pick a face. So the example here, if I flip back, you see the front left that had the 80% glazing applied. So what I'm showing here is you can actually pick on an individual face using the tab key to move through the model until you find the face that you want, and then specify for that, okay, you know what, this bird hide that's the front of the building is only 16% glazing on that face, and it has a shade, and that shade extends 2 feet out, and even you might want to change the material to something maybe that's of a higher insulation value. Well, you can go through this and do this with all the faces, right? So and then when you've done that for the materials on the surface, you can also do it for the glazing itself, right? You could actually pick the glazing and say it's not from the energy settings, but you've got a drop down list and you can say it's not the energy settings. You pick on that, use the drop down list and say I want this to be double pane tinted glass. So you're able to be quite specific about what you want. So the illustration here shows how the percentages of glazing and the materials have been applied now to the building without me actually having to draw anything. When I run the report, it took about 30 seconds. I can get information back like what's the life cycle energy cost, or what is the net CO2, the annual carbon emissions, 5 tons per year. Well, I can go into my model, my mass model, so looking at the building under study as its mass form. I can grab, say, the end of that mass form and just literally pull or push it back to make it a different size. So if I push it back, my updates are applied immediately, and then I can run the second study to see how it compares with the larger building that I had before. So I run the second study and I find out that there's a saving in the life cycle cost, which you'd expect the building's smaller, and a saving in the net CO2. But I can quantify this, right? Nobody's saying that these are final answers on exactly what the life cycle energy cost would be, but now you've got a basis for comparison. You can validate changes that you make as being for the better or being for the worst. You can also run solar radiation studies. So for example, these kids are able to say, well, in Accrington, Lancashire, this is the amount of energy that I would get, available to the cumulatively on the surfaces of my building, 520 kilowatt hours per square meter. Well, we can then have them change the location of the building, maybe move it to Southern California, pick a different location, and then click on the button to do the solar radiation again, and they learn what the impact is of the environment on the building that they're studying. So they see that there's actually almost twice as much energy available in San Luis Obispo. Again, quantifiable results, not intuition. So if they move their building back to England, they can do things like place a adjustable solar panel on the roof, and they can do the solar radiation studies again and find out what's the optimum tilt for the photovoltaic panels that they want to put on the building itself. So they get a lot of great information. Now, if they needed to, if you look at the example on the top right, you can actually draft openings on the surfaces. You don't have to use the settings that are in the product. So if for some reason you wanted to create a model for analysis that actually had the openings in the position that they actually are in the finished building, you can draft it that way. So the example on the bottom right shows that you can even create these openings on curved and complex surfaces. I'll show a bit more of that when we eventually get to the movies. So you've got now the comparative studies, solar radiation, and you've got the comparative energy costs. I'm only showing 2 of the values that we got back. There's, as you'll see in the movies, there's a lot more information that you get, but I can see what my savings were from one to the other. The students in doing this, they don't need to get caught up in specifics. They know there are assumptions behind the analysis, such as the energy costs in their district. But as long as they see Vasari as a tool for comparison, for conceptual design, not as validating precisely how much energy the building uses, they know that they've got something that's very useful to them. And they also know that they can get a more detailed analysis on maybe specific areas within the building, even from other tools like Green Building Studio or Ecotect Analysis. So they're able to shape the design, shape their future for this building by making changes and getting quick feedback, what if scenarios, and looking at design alternatives. Well, undergraduate students too are very interested because they get to create context and they get access to useful tools and immediate quantitative results. So this particular model is a model produced for New York. One of the things I usually point out to them is that schedules are generated automatically. So even in a complex building where the form isn't simple like the one for the classroom. So I'm going to move on from this. I'm going to make a number of movies to show you how the project works.